Okay, today we're going to be talking about intermolecular forces chemistry. So, there's 6 main different types of forces that you're definitely going to hear. And those are London dispersion forces, dipole-dipole forces, hydrogen bonding forces, ion-ion forces, ion-dipole forces, and dipole-induced dipole forces. So, London dispersion forces, they're also known as van der Waals force and induced dipole forces. And these forces, you just have to know that they appear in all molecule bonding. Doesn't matter what type of molecule it is, it's always going to be appearing. However, dipole-dipole is kind of like the opposite because it only occurs with polar molecules. So if you have a non-polar molecule, you will not see dipole-dipole. For polar molecules, you will 100% see dipole-dipole. Hydrogen bonding only occurs when a hydrogen is bonded to a fluorine, oxygen, or nitrogen atom. So if it was bonded to anything else, it would not be hydrogen bonding. And the reason for this is because these 3 elements are highly electronegative, which kind of provides for that strong bond. So I gave a little example of a water molecule, and that would be an example of hydrogen bonding. Ion-ion is the attraction between 2 oppositely charged ions. So for example, Na plus and Cl minus. Ion dipole is the attraction between an ion and a polar molecule, but a dipole-induced dipole is the attraction between a polar molecule and a non-polar molecule. So between all of these, the strongest to weakest, you're going to have ion-ion as first, ion dipole, hydrogen bonding, dipole-dipole, dipole-induced dipole, and then London dispersion forces. And I have some important notes at the bottom. So for example, higher vapor pressure equals weaker intermolecular forces. So if molecule A has 700 as their vapor pressure, but molecule B has 400 as their vapor pressure, we know that molecule A has weaker intermolecular forces because of how much higher the vapor pressure is compared to molecule B. But higher boiling point means that there's going to be stronger intermolecular forces and a higher atomic weight. So if we had, molecule A has like 200 degrees and then molecule B has 300 degrees, molecule B in this case has stronger intermolecular forces and is also going to have a higher atomic weight. Noble gases, they only experience LDF, which is London dispersion forces. So that's kind of like something to keep in mind if you have any multiple choice questions and you see that they only have London dispersion forces. And the number of hydrogen bonds matter in determining the overall strength of the bonding, of hydrogen bonding. So for example, if we had H2O and if we had HF, H2O has stronger hydrogen bonding compared to HF. Even though fluorine is more electronegative, H2O is still going to have a higher, or is going to have a stronger hydrogen bonding because of how many bonding points it has. So if you look at the diagram I have right here, it has 1, 2, 3, 4 points of bonding with another molecule. But if we had an HF molecule, which is just H and then F, if we had an HF molecule, that's only 2 bonding points. So the H2O is much, much stronger because it has more points of bonding. And last but not least, I have like dissolves like. So what that means is basically what compound is the most soluble in water. So to determine that, since we know that water is polar and that it forms hydrogen bonds, molecules like that will dissolve better in water. So molecules that are polar and that form hydrogen bonds will be perfect and will dissolve easily in water, but molecules that are the opposite, so like non-polar and primarily interact with LDF, those will not mix well with water. So those are the key points I have on intermolecular forces.